Welcome to September 2nd's LeetCode Challenge, Unique Binary Search Trees 2. Given an integer n, return all the structurally unique binary search tree which has exactly n nodes of unique values from 1 to n. Return any answers in any order. So we give an n value which has 3 nodes, and we return all the unique binary search trees. So we have 1 null, 3, which would represent this tree right here, 1 null, 2 null, 3. They're not in order, by the way. We want to return 1 null, 3 2. So 1 null, 3 2. 2 1 3 2 1 3. 3 1 null 1. 3 1 null 2. 3 2 null 1. 3 2 null 1. Which would be this one, not in order. If we have a node of, let's say, n equals 1, then we return an array of list 1. Okay, there is an iterative approach, and I'm just going to do basically a depth first search type algorithm to depth first search type algorithm, which basically returns, which does it recursively. So let's say if I were to, let's see, return depth first search algorithm of what's called self.dsearch, which takes in values 1 to n. Alright, so we're going to write an algorithm that does that. So the search, which is going to take in basically self. It's going to take in a start and n. So here's how it's going to work. So if start is greater or high or low started than n, then we are going to return none. If start is equal to n, we are going to return a node. Tree node of start. Our output or result is going to be a empty array. So this is our recursive or for loop for I in range of start to n plus 1. We are going to update left subtree to be self dot. So this is where recursion goes. The first search taking in our start I minus 1. Right will be self dot the first search of I plus 1 to end. And then for left in left, for right in right, we are going to make a temporary node to basically tree.node of I, and we are going to temp.left, make that assigned to 1, temp dot, what am I doing? This is going to be left, L, right, assign that to right, and then our result is going to be appended to it, which is going to be our node append.temp. And in all this, you want to basically return our results. So basically, this algorithm runs the depth first search definition. Hopefully, this works. Looks somewhat good. Please work. Accepted. Awesome. So usually, I don't really like making other definitions, but this is a medium type approach to it. And I tried the iterative search, and it worked, but it sucked so much. It's really messy as well. So I think this is one of the more cleaner type of depth first search algorithm. In terms of time complexity, we have run the function once, right, for each n value. So this is n times n times n times n. So it'll be big O to the n to the fourth in terms of time complexity. Space complexity, it stores everything inside an array. But the array also actually goes through the for loop and does a self function as well. So it would be I think it's big. The space complexity would be big O to the h, where h is the height of the tree, times n, because it has different heights times the how many times it has to store that value inside itself in terms of the result stat array here. All right, that's what I think it is. I'm not 100% sure, but and that's it. Have a great day, guys.